Good chief scientist and academic should be robust, diligent, and vociferous, with a healthy disregard of political or, as I discovered, other sensibilities. A model of research and engagement that should be celebrated, set against increasing pressure from academia and funders to deliver policy expedient science. David's meticulous analysis and candid conclusions typically offered refreshing, if challenging, insights. His all too early death is a big loss, but his legacy offers a model of independent endeavour to which we can all aspire. And I think that's just worth remembering that we are paid by the taxpayer to demonstrate academic integrity, regardless of what the research councils tell us, regardless of their strategy documents, regardless of concepts about economic growth. We are there to do thorough, detailed academic research. It doesn't matter whether people like or don't like our conclusions, it's only whether they disagree with them or not that matters, and disagree on the basis of substance. So I think actually, he was a fine example of what we should aspire to in universities, and universities are increasingly moving away from that vision, in my view, unfortunately. So an outline for tonight's talk. Where do we actually stand on climate change at the moment? Where do we stand? I mean, us collectively, think about that in a minute. what should our school report say about climate change so far? We've been playing around with it 25 years, so what would you give us in terms of a school report for that? The challenge in terms of carbon budgets, was Paris rhetorical guff, or was it actually a genuine commitment? What do we think about Paris? And I'm going to assume it was the latter. I take our policymakers at face value. I think they're not liars. They presumably they are saying things that they believe and that we should endeavour to achieve. What rates of mitigation would we therefore need to deliver the 2°C framing of Paris? I will talk about the 1.5 briefly. Why are we so optimistic about climate change? Some people are anyway. I don't know if I get time to talk on this, but if we choose to fail, and notice that is if we choose to fail, where are we heading? Because it's still a choice. And if we choose to succeed, what do we need to do? We need to sort of touch on what that sort of framing might look like. I'm going to start off with this slide here. And I like to think about where are we in this slide? I know nothing about, well, there's only a few of you I know here, so I don't know anything about many of you here at all, other than you've come out on a dark evening to listen to something on climate change, which might tell me something about your views. But, so which is our tribe? The denialists. The world is 5,000 years old. God put fossils there to chip us up. You know, some people believe that. Probably not many people in the USA, in the UK rather. Probably more in the US, living in Texas or somewhere. There are other people who would argue that science is fundamentally flawed. I think there's a very small group of those out there now. I think most of the people who would have said they were denialists who did listen to the science would now put themselves in the skeptics camp. They have moved. And I think Oresky's and Conway's book demonstrates that quite clearly, that big shift of the skeptics or denialists to become skeptics. The skeptics who say, well, the science is broadly right, but no need to particularly worry because the climate sensitivity is very low. Then there's the other sort of Nigel Lawson ones, well, it won't really matter anyway because the economy will be 8 times bigger by 2100, so we can buy our way out of any problems. And they have an element of cogency to these arguments. There's nothing necessarily wrong with some components of the arguments that are given there, whether we like the individuals or not. The incrementalists, which is where I would put 99.99% of all of us who work on climate science. The science is correct and climate change is important, but carbon prices, utopian technologies by people who have never built anything, it seems to be most of the time, will actually be able to deliver on Paris 1.5 and 2°C framing. And it'll be interesting to see what comes out of the IPCC 1.5°C report. My guess is they'll say it's possible with more technology, but maybe not. And I think all of this can be done within the current socioeconomic paradigm. So we haven't got to question the world in which we live in any fundamental way. I think that's where most of us on climate change work. It's where the research councils live. It's where the policymakers are. And I would call that's where the greatest level of dangerous skepticism is actually in that particular group. We are the skeptics. There's the radicals, or as I'm giving away my preference for these now, the realists. Science is correct, climate change is important, but if we are serious about 1.5 and 2°C, and I'm not saying we have to be, but if we are, then it's incompatible with economic growth in the conventional way of measuring it, at least for the next 20, 30 or 40 years. So that's quite challenging. And that climate change out of Paris is actually now, because we've left it so late, is now a system change issue. It wasn't originally, but we've chosen to fail, so it is now a system change issue. So where would we put ourselves in that camp? In those areas. I mean, I'm not asking you to think about where you are within that. I think it's to remind ourselves of our positions and whether they're supportable or not. I'm going to start off with a quote which I regularly use from Richard Feynman, one some of you may have come across. This is when he was the chair of the Presidential Commission after the Challenger shuttle accident. Which obviously wasn't really speaking about climate change, but he might as well have been. For successful technology, reality must take precedence over public relations, for nature cannot be fooled. And I think I'm going to come back to that later, because I think we have collectively as a climate change community and continue to try and fool nature and ourselves. It is a sort of mass collective delusion. My pre-Paris provocation, which I think it is provocation, so it's pushing it a little bit, but I still think this broadly holds, is that in developing 2°C emission scenarios, we've applied questionable assumptions and fine-tuned our analysis to fit with political and economic sensibilities. And that's, of course, how we have to get funding nowadays. If you want to get funding from the research councils, you have to be able to show how it will lead into economic growth. So I think we have not been prepared to question that sort of paradigm, when sometimes our analysis might suggest we should be. I also think, this is really the school report part, that the backdrop to Paris, you're all familiar with the Paris and the IPCC reports. Is anyone not familiar with the IPCC? You probably all know much more about this than I do. But anyway, well, certainly some of you here are younger than me by a noticeable margin. The first report from the IPCC came out in 1990. That's before some of you here were born, 27 years ago. Others of you here were very young and probably weren't too worried about climate change. You were playing with Lego, wasn't it? So, 27 years ago, we had enough information on climate change to tell us it was sufficiently serious we should be acting. And you can argue we had information before that, but I think the IPCC brought that information together. We have no real excuse post-1990. And remember, the first Rio summit was 1992, where it said how important this was. 27 years ago now. The emissions this year will be 60% higher than they were in 1990. Now, that's an utter abject failure. And I was going to put some slides on to show this, but I'll just make it. I think people of my generation with, as I usually say, grey hair, no hair, or dyed hair, we have to apologise profusely to the younger generation that we are handing them this poisoned chalice. We have done that deliberately. We have done it knowingly, because we have not been bothered to make changes in how we live our lives individually or collectively. And we have done that, we've passed it on to our own children, and we continue to do that day in, day out. We're not honest with the next generation about what we're leaving them. So I think we should start with an apology, hang our heads in shame, and spend a bit of time with some humility, and then start to act seriously about climate change. The backdrop to Paris is that, and I think this is really important, this came out in the last set of IPCC reports, and myself and colleagues have been working on the carbon budget framework, which most of this talk will be based on for a lot of years now, and it was really good to see that now embedded within the last set of IPCC reports. Unfortunately, it wasn't embedded within Paris for lots of political reasons. But in terms of temperature, what matters are carbon budgets. It doesn't matter about what happens in 2050. It's all handy what happens in 2050, because that means we can delay it. It's not in my term of office for a politician. For academics, we can carry on flying to conferences to meet our friends. We haven't got to think about the future, because technology will solve it in 2030, 2040, 2050. It has nothing to do with climate change. It never has had. But we've repeatedly been using it as a shorthand, then we forgot it was a shorthand, and now we just think it's right. But 2050 has nothing to do with climate change, nor does 2030. What matters are the carbon budgets. And the more we emit today, the less we can emit tomorrow. And this has profound political repercussions, and that's why we don't like it. That's why we much prefer the scientific literature approach of saying, well, what can we do by 2050? And we as scientists, I think, have fed into that debate unhelpfully. So let's think about these budgets graphically. Well, that's our emissions so far. I'll be showing you a slightly different curve of our history in a few minutes, but anyway. And the carbon budget, which hopefully now you're all fairly familiar with. A lot of people in climate change are now. It wasn't something they engaged with much before, but it is really important to understand that what matters in terms of temperature across the century. There are lots of other things that matter as well, but significantly correlated with temperature is the total amount of carbon dioxide that we put into the atmosphere across the century. That's what really matters. Obviously, if we choose fail doing it about climate change now, emissions keep going up, or did keep going up, then we have to save that later on, if that's possible, of course. So, it's like having a salary, and the more you spend now, the less you can spend later in the month. And you have to have much higher rates of mitigation. And I would argue, when I'm going to try and demonstrate that wouldn't be possible. So let's go back to the Paris Agreement. Were any of you at the Paris event? Not been to Paris, a few of you were there, okay? I think about 40,000 people or something went to Paris. It was a huge event, a very high carbon footprint, I would think, as well. And I think that's an interesting point, that a climate change event is a high carbon footprint. Surely it should be demonstrating something different. But anyway, this is the document. I think it's 32 pages in total. And it's an important read, even if it's not the most exciting of reads. And I'm going to focus on this particular paragraph here. I will say now, I recognise there are lots of non-CO2 issues, methane, nitrous oxide, and so forth. There are lots of other issues, and they represent a significant part of the warming problem. I'm not focusing on that. I deal mostly with energy and climate change in relation to carbon dioxide emissions. I'm not decrying the importance of agriculture and the industrial process emissions and so forth. These are really very important, and a lot of good work is going on them. They're actually much more complicated than CO2 as well in some respects to try and deal with. So I'm going to focus on this paragraph here. And here we've said, and I'm taking it at face value, and as a democracy, I'm assuming that we broadly accept this, to hold the increase in global average temperature to well below 2 degrees. Notice it says well below 2 degrees centigrade, and take efforts to pursue 1.5. It's just worth thinking that the UK government's position at the moment with advice from the Committee on Climate Change is, according to them, a 63% chance of exceeding 2 degrees centigrade. So there's no way you could reconcile the government's current position or its carbon budgets with Paris. A 63% chance is not well below or aiming for 1.5. We've also said to do that on the basis of the best science, and that was actually only included in the final version of the Paris Agreement. The penultimate version in the early draft didn't have the word science in it anywhere. But anyway, after quite a discussion that was put in. And also, we're going to do it on the basis of equity and efforts to eradicate poverty. And I think these are quite important. These are words that are all well and good, and you could say they're rhetorical, but I think you can go much further than them. I think that you can actually take well below 1.02, 1.5, best science and equity. And I think that with some fairly high levels of agreement amongst people, you can say what that means quantitatively within a reasonable envelope. So you can say, what does that mean for the UK? What does it mean globally? What does it mean for the UK? What does it mean for Cambridge University? What does it mean for the way our institutions have to operate? And we can then start to see, are the things that we're doing broadly in line with this? So I think we can quantify Paris sufficiently well now to tell us whether actually the things we're suggesting are in any way in line with what we've committed to deliver. We haven't done that, and we're trying to do it now with some colleagues in Sweden, actually, for a number of municipalities, trying to say what would the municipality need to deliver in terms of its carbon reductions. And we've fed into a few court cases using this as well. The Paris Agreement, for all of its triumphs, I think there are some major problems with it. There's no reference to fossil fuels or decarbonisation. It's a document on climate change. But actually, probably some of you are aware, you listen to the discussions over whether it should have a should or shall in it with the American lawyers. I mean, if it's a shall, then you can take American companies to court, and if it's a should, well, it's just a voluntary, it's a we should diet. It's that sort of thing. So arguments occur over the words. And, we couldn't have fossil fuels in there because we wanted to keep the Saudis on board and probably the Scots and the Norwegians as well. So you can't have certain expressions used in there. Aviation and shipping, we exempt, as they have been pretty much from Kyoto onwards. That's the equivalent of the UK and Germany added together with very high growth rates, both sectors seeing their emissions, even with efficiency improvements, basically doubling by 2050. So a massive rise for what's already quite a significant proportion of emissions. National promises, if you add together the promises that were made in Paris, they add up to probably nearer 3 to 4 degrees C of warming, nothing like 2 degrees C. And the big concern to me is that we're not going to review those, not seriously review them until 2023. Now, maybe we'll bring that forward. There's a sort of a discussion about the review in 2018. So maybe we will. But if not, that's 300 billion tonnes of CO2 from now. And I'll come back later to what that sort of number means. That's a very large amount of CO2. It's a large chunk of our budget that will be gone. And the whole edifice is reliant on negative emission technologies, which I'm going to speak about quite a bit later on. And these now dominate. They don't dominate the discussion, but they dominate the analysis on climate change. They are slowly coming to wider discussion around these issues, but they've been embedded in a lot of the advice to governments for a long time without anyone being aware of it, except for the modelers that are using these particular techniques. So, and let's say there is a lot more discussion now, so that's really positive. Hopefully these slides are going to work, because these are some new graphs I just put in. So this is current emissions again, and I was talking to Glenn Peters and Cicero today, trying to fully understand this little bit here. Does anyone know what that is? It was an El Nino event, and it was the forest fires, significantly driven by the forest fires in Indonesia. And we expect to see another little spike this year because of the additional forest fires that often occur during El Ninos. I mean, that was the huge fire around Indonesia, around that area. There are other reasons as well, but that's a significant part of that. So there we have historical emissions. And before Paris, according to the International Energy Agency, we were heading somewhere in this direction. With climate change, what you mustn't do is apply too much precision to the numbers. Accuracy is fine. There's a big difference between accuracy. Accuracy is what we want. It's roughly 4 to 6 degrees centigrade. It's not precisely 4 or 6 degrees, so it's accuracy we're after. We were heading in that sort of direction. And the thing between now and an ice age is about 5 degrees. So we're talking about very large changes occurring in a very short period of time. Now, with Paris, we're now heading somewhere in this sort of realm, 3 to 4 degrees C of warming. So still far, far well above what we promised to do within Paris. And to stay well below 2 degrees centigrade, if you take the IPCC report, I'm just taking, this is from the synthesis report, I've taken these carbon budgets. The carbon budgets remaining from 2017 is something like 800 billion tonnes of carbon dioxide that we can pump into the atmosphere. Now, it could be a bit up or down on that, depending on what, exactly which model ones you take, but that's their sort of headline number in the synthesis report, table 2.2. 800 billion tonnes. And that's me making allowance for the fact we're in 2017 now, but of course, the report works them out from 2011. So you have to make allowance for the fact we're not in 2011 anymore. So that makes quite a big difference to our emissions. So 800 billion tons of CO2 that we can emit for a reasonable chance or good chance of 2 degrees centigrade. And if you plot that out, it looks a bit like this. Now that looks nothing like most of the scenarios you'll get to see when people talk about it more widely. No one ever talks about anything that looks like this. I mean, you start to play, look at this 2050, zero emissions basically by 2050 at a global level. I remember we signed up on equities. It was much earlier for people like us, much earlier. It doesn't mean zero emissions from electricity. It means our planes, our ships, our refrigerators, our cars, for 2 degrees centigrade. And let's be clear, 2 degrees centigrade, many people will die at 2 degrees centigrade. They'll be poor, they'll be low emitters, they'll typically be non-white, and they'll live a long way from here. And if we're really blunt about it, we've never cared about them before. And if we really cared, we'd be doing a lot more than we are now. So collectively as a community, we again, as a society, we have chosen to write those people off. So I think it's quite a sad situation to be in. And if we are to do this, you can see why people don't want to do it, because you can't deliver. As an engineer that used to design and build offshore oil platforms, I like bits of engineering kit. You can do a lot of wonderful things with engineering. There are some fantastic bits of engineering out there, but you cannot perform miracles in time. So to get off this curve and onto this one is very challenging indeed. And I would argue this is why we need immediate cuts in energy demand. If we cut energy demand today, then you cut the amount of carbon. You switch the lights off in here, the amount of carbon goes down. So we can immediately affect the amount of carbon that's put into the atmosphere. And that carbon will be there, 20% of it for 10,000 years or so. Now, is this a robust assumption? Is it a robust assumption to say we cannot build our way out with solar panels, wind turbines, nuclear power stations, whatever it might be? Well, I've just used here an example for nuclear. I've used this quite a lot with people. I engage a lot with people in the nuclear industry, but I also engage with people in the renewable energy industry. And people who like these particular technologies, they have a particular favorite. And this is the one that's going to solve the problem. A lot of people have their sort of silver bullet technology. And nuclear energy has that, but so do the renewables. And I think it's all wrong, regardless of which technology they choose. My position is that I'm agnostic about nuclear. It's very low carbon, about 5 to 15 grams of carbon dioxide per kilowatt hour across its life cycle, something like that. Similar to renewables and far, far lower than carbon capture and storage, which is not low carbon, it's just medium carbon. If you take the upstream emissions from it as well. The global final energy demand has probably gone up a bit. This was a couple of years ago, and we've gone up a little bit since then. 105,000 terawatt hours. That's final energy demand, not primary. Electricity is about 20% of that, which is for most industrialized parts of the world a bit higher. Something like Sweden, it's 30%. In France, it's near 30%. But basically, only about 20% of the energy we consume is electricity. Nuclear provides 11.5% roughly of the world's electricity, which then working out is about 2.5% of the world's energy use, energy demand. And it does that with 435 nuclear power stations. So you can start to see, where this clearly goes. Say you want to provide 25% of the world's energy with nuclear power. And you've still got to provide the other 75% from other very, very low carbon, if not zero carbon. Say you were going to do 25%, assuming no growth in energy demand. That's about 3,000 Sizewell, 2 to 3,000 Sizewell B reactors need to be built. Sizewell B being the biggest one in the UK and the newest one that was only commissioned in the 1990s. So it's about 1.2 gigawatts. 3,000 of them have got to be built and operating, planned, constructed, commissioned, and fully operating by 2040. And in between as well, because there's a carbon budget issue. So you can't just wait till 2040. You've got to be doing it from now. So we need to be commissioning and completing about 100 of them every single year. Very large nuclear power stations. We're currently building 70, almost all of which are either delayed or over budget. Not all of them, but many of them are. So what I'm just trying to argue here is you cannot build your way out with bits of shiny kit, however much some of us may like that to be the case. Now, these are important. We have to use bits of engineering to solve some of the issues, but they are not going to resolve the climate change issue. So I would argue, yes, the supply is important, but actually you've got to cut demand in the near term to extend the window for us to be able to put the supply in and still stay within our carbon budgets. So it's a prerequisite that we reduce demand. The supply side, as I said, is important. We can't get away without it. We have to make the transition to zero carbon. And I don't really mean just low. This is a real problem, actually. We need zero carbon. If we keep putting carbon into the atmosphere, the temperature will keep going up. So we've got to get down to as near as we can to zero carbon. So low carbon isn't really good enough. Now, initially, it will be more low carbon because of all the life cycle emissions. But over time, as we make more of the energy system low carbon, those emissions will drop lower and lower and lower at a life cycle level. Now, we think that this is a global picture, and in Paris, we signed up on the basis of equity. So equity is really important at Paris. It was of the Camp David Agreement. It was of the Copenhagen Accord. So equity has always been enshrined in these agreements. And again, I'm taking them at face value that the people signing it meant what they said. And basically, the wealthy nations will have to lead in making a transition to zero carbon. So the poor nations will have longer to make the transition than the wealthier nations. Not much longer. So if you now go back to the carbon budgets and start to think, well, what would that actually mean? Well, the first thing I'm going to touch on is 1.5 degrees centigrade. And you can see why it was pushed. It was pushed significantly by Bangladesh and AOSIS, the Association of Small Island States, because these parts of the world are going to lose where they live. Some of them will lose the whole country. Some of the islands will simply go. And some of the parts will become very hard to sustain a reasonable living in. Now, and remember, that's been knowingly imposed on them by our lifestyles. If they were to do that to us or to the Americans, do we think we'd just sit back quietly and let them carry on? If the boot was on the other foot, would we just do that? We wouldn't, would we? We would have been down there we would point all our weapons at them and told them they better change their behavior overnight. So that's one climate change option, is to start to arm the poor parts of the world. That wasn't a serious suggestion. In 3 to 13 years from now, we'll have used up all of the 1.5 degrees C carbon budget. So I would argue it is now too late for 1.5 degrees centigrade, unless we find some other sort of technology to help us out of this that I will talk about later. I'll put a question mark in brackets because we're not there yet, so maybe there is something we can do. For 2 degrees centigrade, and I've taken the maths out of this, but we can talk about this if you want to. But broadly, the poorer and the less industrialized countries, and to be blunt, they're dominated by China, who still has very much lower emissions per capita than we do in the West, if you take a consumption-based account of it. This laptop was made in China. Probably some of my, hopefully they weren't, I tried to buy European clothes. Maybe some of my clothes are made in China. So they make a lot of the things for the West as well. If you take that into account, their emissions are still much lower than Europeans and far, far lower than the Americans. So it includes China, but they have to peak their emissions very rapidly, probably by the mid-2020s, and then head to zero CO2 energy by 2050. So 2050, zero CO2 energy. And you can work out the carbon budget for that. It's quite straightforward to do that. You get a little envelope of what those budgets might look like, but because we're leaving it so late, that envelope is quite tight. And then you can take that away from the total global carbon budget, and what you have is what's left for us. And basically, we have to be reaching zero carbon energy by about 2035. So we've got, how long does that give us? 18 years, something like that. And we can allow ourselves a year or two over, or maybe a year or two less, but that sort of time frame. 18 years to be zero carbon everything. Now that is over 12% per annum reductions in emissions, year on year, starting January the 1st this year. So we're already, we're 2 months or so behind schedule. 12%, over 12% is for the UK every single year. And I still would argue this is equitable. There is no equitable way of splitting out a carbon budget anymore. There's just less inequitable ways of doing it. That means we need to be about 50% reduction in emissions by 2020 and about 75% reductions by 2025. Now, there's some guidance for what we should be doing in our universities. I think what that means, all universities are trying to attract international students. What do you do about that? Because they fly here, they have developed relationships with other international students from elsewhere in the world, and they have families all over the place. We are facilitating a system which is very, very hard to maintain without massive uses of fossil fuels. So these are fundamentally profound questions for institutions, even like universities. So all this is fairly depressing. So why is it we saw such euphoria in Paris? And, we hear this repeatedly, whether it's the Sterns of this world or the DiCaprios of this world, which is probably a bit unfair. He's a bit more realistic than some of the others, I think, or the Gores of this world. Why is it like this? Why is it they're so enthusiastic? Well, actually, I think we take some significant responsibility for that as a climate change community. But the policymakers have received a very different story to the one I'm telling here, and I've been told repeatedly by lots of academics that I should not be saying this, and they've been telling me that for 10 years. I shouldn't be telling stories like this. Away from the microphone, most of them will say they don't really disagree with what I'm saying. There may be nuanced differences here and there, but they think it's irresponsible to be putting out this sort of message. And I think that's not the job of academics to care. Again, as I said before, whether people like the message or not, it's just to try and do the research carefully and communicate it bluntly. So why is it so different? Well, the advice that the policymakers have been given has been dominated by a particular group, the integrated assessment modelers. Spell modelers wrong. Probably got American spelling on it. And they have a much larger carbon budget, or they use a much larger 2 degrees C carbon budget, despite the fact the IPCC gives them a fairly clear carbon budget. And therefore, the mitigation challenge is much less. In other words, it's much nicer for policymakers to talk to the integrated assessment modelers than to do a bit of basic maths. This is the median, roughly, approximately, the median budgets, or the median pathway taken from the IPCC 2 degree scenarios. There are lots of scenarios were submitted by the integrated assessment modelling groups to the IPCC. This is their median plot, and it was taken from a paper that Glenn Peters and I had in Science a little while ago. Why is that so much bigger? It's about 1,400 billion tonnes. Remember I said we only have 800. So how come they're doing 2 degrees C at 1,400 billion tonnes? But actually it's not 1,400 billion tonnes when you really look at it, because you'll see here that it starts quite a lot lower than actual real data. So you blow up the real data, and that gives you an extra 4 billion tonnes on top of what they're using. And then you start to say, well, we better fill that in, make some allowance for that. And you start to play around, what would this budget actually look like to fit in this? And it's going to be something like 1,600 billion tonnes. This is the median. I mean, there are quite a range, but virtually every single 2 degree scenario for a likely chance of 2 degrees C that was submitted to the IPCC includes negative emission technologies, which is going to lead to in a minute. So that's twice the size of the budget, twice the size. That's what the policymakers get to hear about. Now, for a likely chance of 2 degrees C, what I'm saying here, just to reiterate this, we have about 800 gigatons. The advice we're giving to governments is we've got about 1,600 gigatons. So it's halving the size of the challenge. How can that be the case? How can this make any sense? These are both IPC Working Group 1 and Synthesis Report, IPCC Working Group 3, full of economists and engineers and scientists coming together to paint cost-optimal solutions to a problem. And that's because they've all chipped over one of these people, pulling rabbits from hats. I don't mean this to be flippant, but actually this is effectively what we've been doing. It's fine to pull the odd rabbit out of the odd hat, but if every single modelling group is pulling rabbits out of hats, then it becomes a systemic bias. They're using negative emission technologies, and there are virtually no exceptions to this. And they're going to plan to suck, if you look at it across the century, hundreds of billions of tonnes of carbon dioxide, hundreds of billions of tonnes, not a handful, but huge quantities across the century. This is the median figures, again, taken from our science paper. This is the negative emissions that we apply on top of this. But the other thing to notice here, they don't go down to zero, or at least quite a lot of the scenarios don't. They carry on doing this after the end of the century, and also you can carry on emissions to some extent after the end of the century as well. And that's what we're relying on. That's what we're handing over to our children, that hope, that belief that this can just carry on. And the dominant technology, and I think it's fair to say that all of the models, again, use the same technology at the moment, is BECCS, biomass energy with carbon capture and storage. And you probably are quite familiar with this now, but not a lot of people were even aware of these technologies a little while ago. But we're going to grow trees and plants in very, very large quantities. We're going to, as they grow, they absorb carbon dioxide through photosynthesis. We're going to burn those trees in our power stations once we've shipped them around the world, once we've built the shipping industry to move this huge quantity of wood and plant material all around the planet, burn it in our power stations, capture the carbon dioxide, liquefy it or almost liquefy it, and pump it somewhere underground and store it there for a few thousand years. That's what we're relying on, rather than find a way to transport 70 kilograms of, or in my case, 90 kilograms of flesh, 6 kilometers to pick up my groceries without carrying with me 2,000 kilograms of car, which is what we do nowadays. We have normalized practices that just use huge quantities of energy. And we don't want to get rid of those, so we're going to carry on doing this. This has never worked at scale. The only big carbon capture and storage plant that we've got experience of at a power station level is the Boundary Dam one in Canada. And that's had real major problems for the last 2 years operationally. And I'm sure that as engineers, they will solve it. But it is not proved easy. And that's just with using coal, not using biomass, which is much more chemically heterogeneous. So the huge technical economic unknowns, the massive efficiency penalty. Most power stations, even if it's running near its current efficiency, will be nowhere near 60%. It's probably 35 to 55%, most power stations. You bolt on the end of that a CCS plant, which is a real bit of sort of engineering grunt technology. It's not sophisticated. And what you do is you make the thing even 15 to 20% worse efficiency than it was before. And you then transmit the power in the cables, which is 2% loss in the high voltage ones and 5 to 6% loss in your local distribution lines. And eventually you get a few electrons stuffed at the end of your cable. I mean, this is where we're heading in 2017 to 2100. There's limited biomass availability. We want to feed 9 to 10 billion people. We want to have biomass to drive fly our planes. We want to have biomass in our chemical industry. And we might want to think that some of the world would actually be things like natural parks or rainforests or things like that as well, rather than just all being there instrumentally to allow us to burn more carbon. If you put together the models and say, what do they look like in terms of area, about 1 to 3 times the size of India, most of them about 1 to 2 times the size of India, that you would have to plant every single year. And I often say, I think if you're Brits, then we probably think it is India because we're still quite colonial about these things. You'd have to do this year after year, decade after decade, to well on the end of the century. I mean, it just starts to sort of think, is this reasonable to rely on? And the other way of thinking about it is that we currently pump out about 40 billion tons of carbon dioxide every year, of which half disappears into the oceans and the plants. And that what we're planning here is that by the middle of the century, could be moving towards something similar in terms of about 5 to 10 billion tons absorbed by this new technology, and by the end of the century, somewhere approaching the amount of carbon dioxide that we actually absorb currently in the biosphere. So it's like having another biosphere bolted alongside. This is again, just to give some sort of flavour of the scale that we're talking about. So I would argue that Paris, some academics and politicians, rather than focus on urgent and deep mitigation today, now, because that has huge challenging economic and social repercussions, we'd rather rely on non-existent technologies at some point in the future to suck hundreds of billions of tons of CO2 out of the atmosphere. This is what we're relying on. Now, let me be really clear. I think we should fund research and development into negative emission technologies. I think it's really important we do that. I think it's really important that we assume they will not work. They may work, and if they work and we've aimed for 2 degrees C seriously, then perhaps we can aim for 1.5. Maybe if they work at that sort of scale and we haven't had lots of other feedbacks, maybe that would help. But actually, to assume that they will work and to allow us to build airports and fracking and everything else on the basis of this technology is incredibly dangerous. Also, it's interesting, isn't it, that this is highly speculative. And at the other end of the system, these are highly speculative and make the budgets bigger, make it easier. At the other end, of course, there are similarly speculative positive feedbacks, like the increased metabolism within soil. And there's a paper out in Nature last year that showed, before Christmas, that showed that, or estimated with a large uncertainty band, you could get another 200 gigatons of released CO2 from the metabolism in soil. So there are other things out there that could be changing the balance. But we don't think about those, because they make the budget smaller, they make the challenge harder. We only think about the things that make it easier. This is might be a really deep systemic bias that we have had in our community. Now, I'm not criticising some of the people that have been doing this either, not individually, but collectively I am. And I think we've had a whole shameful litany of these scams. We had offsetting, which is paying other people to diet for you. I mean, I would argue it's worse than doing nothing from a carbon perspective. And I've actually wrote something about that in Nature some time ago, and I'm happy to discuss that later. So I think offsetting might have good development benefits, but from a emission point of view, CO2 point of view, over the century, I think it's worse than doing nothing. The clean development mechanism, which allows big fat countries like the UK to pay Ghana and poorer parts of the world to reduce their emissions whilst we expand our airports. That was the clean development mechanism. So we sanctioned it officially in governments. We had the emissions trading scheme, but we pumped out so many permits that we knew the price would stay really low and make very little difference at all. So it barely tickled the industries. And now we've got negative emission technologies, biomass energy carbon capture and storage, and you'll soon start hearing, and some of you already will have done, about solar radiation management. So there are a whole suite of things people are talking about out there. My argument, when are we going to try mitigation? When are we actually going to try and reduce our emissions? We have tried every scam under the sun. No doubt we'll come up with some more. Economists are very good at coming up with more scams. But we need to actually start to reduce our emissions. And maybe some of these things work. Nets and so forth. So we were a bit more successful with the 1.5. And so I go back to Feynman here, and I think we have not taken notice of what he said. We are and continue to try and fool nature. And I also make the point that nature's been there for a long time. We've had 13 billion years or so of physics, and it's been pretty reliable. we've had 30 years or so of ephemeral current economic frameworks, and they've already sort of collapsed in 2007. So why is it we're so wedded to what looks to be like a fairly failed economic paradigm in some respects, and yet we take no notice of the physics that we're taught at schools? So, where? 5 or 10 minutes. Okay. Excellent. Right, I won't do this bit then. I was going to go to impacts, but you're probably familiar with these. 4 degrees, you're right, 4 degrees C or 2 degrees C, it's a global average, very unhelpful. Scientists shouldn't use it. We should be talking more about what the regional repercussions are, because obviously that's what people see. If you live in Manchester or Uppsala in Sweden, 2 to 4 degrees C warming sounds quite pleasant. But big impacts in heat waves, you could see 8 to 12 degrees additional warming on top of heat waves, You could see increased problems with production of yields, not actually total production, but yields in the southern hemisphere from staple food crops, maize, wheat, sorghum, these sorts of things, and sea level rise, very uncertain. I mean, I'm trying to sort of pull the various things that are out there, somewhere between half a metre and a metre and a half by the middle of the century. And I think, if some of you here tell me if I'm wrong on this, but it looks to me, from the people I've spoken to about this, that if we head towards sort of 2 degrees C, that will probably in the long term lock in Greenland, most melting of Greenland. Does anyone disagree with that? Does anyone here work on that sort of ice side? No. Yeah. That's my understanding. Yeah. That's got 7 meters of sea level rise in it. 7 meters. Yeah. When you think about Cambridge, it's got some beautiful things in Cambridge. Most things that are beautiful in Cambridge, as well as the people, are the old buildings. We think there's something special about our history, our legacy, about seeing human civilization evolving, not suddenly flooding it with water. So we're talking about doing things now that will destroy the places that we think have some sort of human heritage value. 7 meters of sea level rise. That will change the gravitational patterns on the planet. That's what we've managed to do as a civilization. If it wasn't so sad, it would be quite incredible that a handful of people on the planet have managed to, within about 50 to 100 years, change the planet so much that if it does melt, which it probably is going to, if it does melt, actually the sea level rise in Greenland will be quite low. Because of the way the waters then spread down the planet, much more of it will get pulled to the southern hemisphere. So we are changing those patterns. Incredible and sad. So at 4 degrees C, I would say most of the scientists I talk to on this, and other social scientists as well, would say it's incompatible with organised global community. We don't see any way we can survive in that future. Some people might survive, but we will start to fight. The usual thing that happens when we're stressed is that men reach for guns and kill each other and everyone else as well. And we've seen that in other places where communities have been stressed by droughts and so forth, in addition to other tensions. It's beyond adaptation, as far as we can see, devastating to ecosystems, not just the emblematic ones like the barrier reef and the rainforest, but actually the ones that pollinate our crops. So other things like that. And highly unlikely to be stable. Some of you here might know much more about this than me, but there's a lot of tipping point issues that may be there, or non-linearities. That as we head towards these sorts of temperatures, we're likely to see some increased warming over and above the standard CO2 climate sensitivity ones. So I would say here that 4 degrees C should be avoided at all costs. And I deliberately emphasize all there because that stops economists discounting the future. Because economists are always good at saying you're better off leaving it till tomorrow. But if it's at all costs, it doesn't matter what your discount rate is, if there are any economists here. So let's go back to 2 degrees C. Is it still viable? I think it is, but only just. And the last few slides I wanted to touch on these here. Technology, supply and demand, and then equity. And obviously on the technology side, that's my main interest, because that's the bit I come from, that sort of background. But actually increasingly I'm starting to recognize that it's much more the sort of the social side that's the big problem. In fact, technologies don't exist in and of themselves. They're social technical regimes, as my social scientist colleagues tell me, which is a very, very unhelpful expression. They need to find a better way to make it more punchy term. But technologies always interact with society. We shouldn't see things as technologies that plug into society and they would deliver what the engineers expect. That never happens. So we have to think of technology as something that we interact with. So the solution space becomes much more complicated. So for electricity, there are plenty of things we can do. This is geothermal in Iceland. This is wind turbines offshore. This is a nuclear power station where my dad used to work, and that's the sizable PWR behind it. So this one's now, it's sat there waiting to be decommissioned. It's an old Magnox station. Dams in the States. Solar panels, all of these are very, very low carbon. Biomass, a lot of problems with biomass, lots of stability implications, big issues with storage. It can be very high emissions, it can be low emissions, but there are lots of difficulties with biomass. But used appropriately, it can be sustainable and low carbon. Tidal energy, which we have lots of in the UK, but we've not used any of it. Wave energy, Again, low carbon, some big issues there still technically, I think, to resolve in that in terms of getting lots of energy out of it. And then carbon capture and storage, which I say is not low. It's about 100 to 200 grams of carbon per kilowatt hour if you take the full life cycle emissions into account for CCS. And most of that's the upstream side. So there are lots of things you can do, but these are all electricity. And electricity is 20% of the energy we consume. So what about the other 80%? So we need to do something else as well. And I would argue that we need to have a massive program of electrification as well as reducing our demand. So we electrify heating, or preferably we retrofit our houses so we don't need so much heating, but anyway, heating, industrial heating as well, transport, you know, and a lot of those other things that we might be able to electrify in one way or another. They're talking now about electrifying some of the ferries in some of the islands around Sweden. So there are things that we wouldn't thought were possible before, but may be possible in the future. The demand side, there are huge things you can do on the demand side. And that's probably where myself and what my colleagues at the Tyndall Centre in Manchester have been focusing our time and attention, looking at what can we do on the demand side. I'm not going to go through the details now. There's been plenty of work historically to show what you can do technically without any, you know, any new bits of kit really, just with existing technologies. If we had efficiency standards that were really tight, not just sort of weak ones, but really tight and were compulsory, and they were tightened year on year. Okay, the financial directors will squeal in the companies, but the engineers will relish the idea they've got a new specification sheet to design the kit to. So, you know, listen to the engineers, not the financial directors. This will provide long-term market signals, and the companies will just literally deliver on most of these things, as long as they're in the basic laws of physics and engineers, you know, and the broader rules of engineers, not just quite as simple as physics. Then wealthy nations, I would argue, can reduce their energy consumption by about 40 to 70% in 10 years. Now, when I say this in Sweden, I get some odd looks, but the Swedes use about twice as much energy as the average Brit. And that's given the fact their houses are 5 times more efficient, or a lot more efficient than ours are. I mean, ours are, the best house in the UK is like a Swedish tent. Yeah. And the Swedes have still got quite a long way to go to improve their efficiency. So what I'm saying is that we've got a huge gap. So we could actually be filling that gap with retrofitting our existing houses. And there are some real merits to doing that from an employment point of view. We also have to think about the rebound effect, which I'm not talking about now, but there are things you can do to stop us spending the money that we would save on a jet ski or another holiday. But if you add up together all these technologies, this does not deliver us anything like 2 degrees centigrade. This is the problem, is the technology cannot do it now because we've chosen to fail for a quarter of a century. We could have done this if we started in 1990. But because we haven't, we're in 2017 with almost no budget left. So now we have to do something else. We have to have rapid and deep changes in what we do, how often we do it, and when we do it, and so forth. And this is critical. We have to start to look at these issues. And I don't just mean as individuals, I mean as collectively as society, but often that means we have to catalyse that as individual action, as institutional action, and so forth. Now, there are huge benefits to thinking of it like this. First, there's a massive CO2 asymmetry globally, and indeed within the UK, and probably within this room as well. The Pareto's rules broadly hold. Probably 80% of the emissions from people living in this room now come from 20% of the people in the room. Yeah, it'd be something like that. It's a rule of thumb, but it's a pretty good rule of thumb. Piketty's work, and in fact the presentation I went to earlier this afternoon pointed this out as well. About 50% of global emissions come from about 10% of the global population. So it's not just in the wealthy parts of the world. There's about 300 million people in China live like the average European. The top 1% of US emitters have carbon footprints that are 2,500 times higher than the bottom 1% globally. 2,500 times higher. In a time when we say climate change is important, we have that level of a sort of seen difference. You know, if it was 50 times or 30 times or 100 times maybe, but 2,500 times. And this is what I find, I occasionally check this about once every month probably, because I can't believe it. But if the top 10% of global emitters were to reduce their carbon footprint to the level of the average European citizen, the EU citizens actually, not even European citizens, that would be a 30% cut in global emissions. Isn't that incredible? Now, is climate change important or is it not? If it is important, do we think that at least for maybe 20 or 30 years, that those of the people in the top 10% could have the footprints, the level of the average European, and then obviously have to reduce beyond that, but at least initially to start off with doing that. Even if they reduced the level of the average American, it would be a 15% reduction. And compare that with Paris. The commitments to Paris are for no reduction globally by 2030. And there's a real brutal logic with carbon budgets. You see the backdrop of a plane here. The example of aviation, I'm just using this here, is that every ton of CO2 that we emit, now whether it's from flying or some other activity, but some sort of fairly profligate activity, over and above what we think is a reasonable carbon budget for people, gets added to our other high emissions. Because remember, only high emitters fly. We like to think the poor fly, but the poor hardly ever fly. The wealthy fly more regularly. That's what's happening. The data is really clear on that. Airport growth is driven by wealthy people flying more often. And if you've got a carbon budget, every ton that we emit over and above some reasonable level is the ton that a poor person can't emit. If you understand the budget, unless you've got negative emission technologies or flying pigs. And in the short term, we know that for poor people, having access to energy improves the quality of their life. So what we're saying when we decide to get on a plane, when you think about planes, there is the pinnacle of our success in terms of CO2 emissions. Well, perhaps space travel. I think that's powered by hydrogen peroxide, I think, isn't it? But anyway, so if you fly to another conference, a meeting, or on holiday somewhere, what we're saying is we can't do that and poor people have access to energy for their basic needs. It's a choice. As we step on the plane, we're saying to the poor people, less energy for you, lower quality of life. I don't know if there's a way out of that. If you can explain a nice way out of that, what I think is a really fairly brutal outcome of carbon budgets. We can't have both. So who's in the top 10%? Because once you decide this, you think, well, who's in the top 10%? Now we can aim at them. That's really helpful from a policy perspective. Ahead of me there, I think. Here we are, climate scientists. So, the climate scientists pretty much, there might be some exceptions out there, but I doubt there are. And I think you could probably put every other academic in there as well. And yet every student is aspiring to be there as quickly as possible. Why do you come to university? To get an education so you can get a better job, get paid more money, bigger house, bigger car, fly first class. You all come here, if you're a student, you've come here to try and increase your carbon footprint. That's what you're here to do. And you come to Russell Group University because you think you do it faster than if it was an old poly. So, it's all moving in the wrong direction there. Business leaders, they have to fly around the world because the business has got to be really, really successful so they can pay their taxes so we can build expensive renewables, if you think renewables are expensive. That's what I hear from business leaders. That's why they have to do all of this. Policymakers, they like to spend a lot of time wandering around the world seeing other examples of how not to do things. Frequent flyers, if you get on a plane once or twice a year, then you pretty much guarantee you put yourself in that category. And if you turn up at a climate change event, then you're almost certainly in that group. Again, there might be some exceptions. But people attending climate change talks basically have got plenty of spare time in their hand, probably some money in the bank. And so we know who the 10% are. We see them when we shave or put our makeup on. So I would argue now that equity reframes a lot of this and gives us a lot of ways to think about these issues. It's not an issue of 7 billion people. It's an issue of about 1 billion people, even less than a billion people. So 1 to 2 billion people. That's who we have to aim the policy levers at. That's quite different to trying to think of generic policy levers aimed at 7 billion people. It begs questions about things like taxation and so forth as well. This huge asymmetry and responsibility gives us a whole suite of opportunities that rapid and near-term reductions are possible without having really draconian lives. The average European is not a really poor quality life overall from its carbon from their carbon footprints, from our carbon footprints. So just asking people to do that for a decade or 3 whilst we put low carbon energy supply in place, is that too unreasonable against an existential crisis? Well, at the moment it is too unreasonable to ask that, but we can think about it again. And I would also argue, even though I don't particularly like the idea of role models, I don't like the idea of celebrities or role models in any way, but actually society seems to rely on these. And if people start to make these sorts of changes, they can lead by example. So if any of you watched Before the Flood from Leonardo DiCaprio, I think he comes across, I've written a review of it, I'm quite critical of a lot of the things about the film, but I think he comes across of actually seeing through a lot of the optimistic technical guff that's in there, or that people are talking about rather, and he reckons it's really important. But the time he really squirms is when the Indian woman points out to him about his carbon footprint and his lifestyle and that of the other Americans, and then telling the Indians they should do something different. And he finds that really difficult. But I think actually, if when he went up and picked up his Oscar, he went there by public transport, if when he flew, if he was to fly, he flew economy class, if he started to live a life broadly in line with what he believes, then I think that would be a massive role model to a lot of people. And it would start to provide some change within other people in the industry. So I think there are lots of reasons we need to lead by examples, not just the DiCaprios, but the scientific community. As academics, we need to be doing that as well. And we can catalyse system change. If every university in the UK started to put its own house in order in terms of carbon footprints, it'd be very hard for the universities to turn around, the governments to turn around and say, we're going to take no notice of what our places of learning are telling us. But at the moment, they can look at us and we're doing nothing any different to what the governments are doing. So I think we can demonstrate leadership and we can help catalyse the change. But ultimately, the change will be system change, not individual change. That's the point. Climate change is system change. If we interpret Paris through the logic, the scientific logic of carbon budgets, that begs fundamental questions now of our norms and our paradigms, questions we do not want to ask. We're going to have a Marshall-style transition of, towards low-carbon energy supply, very low-carbon energy supply. That's like the reconstruction of Europe after the Second World War. We're going to have to change the productive capacity of what we do now with a lot of industries. They're going to have to retool towards a low-carbon future. That's simply possible. There's lots of employment opportunities in that. And we've done that before at times. I'm not saying the war metaphors fall apart quite quickly and aren't immediately very attractive. But you could say it's an employment, and there's fairly high employment during wars. So you could say it's an employment opportunity here, that we actually shift across to retrofitting the 17 million of the UK households that will be here in 2050, as well as moving towards renewable energy. We need to have a massive penetration of end-use efficient technologies, which we can do very quickly. There's a 2- to 4-fold difference in most technologies that we have that are available on the market today, whether that's cars or computers. We need a profound shift in behaviours and practices. Now, that will initially be triggered by individuals and then groups of individuals making those changes, but that then needs to catalyse system change. So we've got to be vociferous about it as well. But the system change we're trying to push for there. We need an economics that's not an oxymoron, we need an economics that's fit for purpose. And I don't think the current economic framing and think about these issues is fit for these sorts of systemic issues. We take marginal economics, neoclassical economics, which is broadly about small changes to systems with infinite number of consumers and infinite numbers of suppliers. The world isn't like that we're dealing with in climate change. We need a new form of thinking about this. We wouldn't do that with quantum mechanics. We wouldn't apply Newton to quantum mechanics. So why are we applying marginal economics to non-marginal problems? We need to think differently. There are plenty of other economic models out there, ecological economists and so forth. There's one sort. We need serious consideration of inter- and intergenerational equity to think about our own children's future, but also other people living elsewhere in the world who are already being impacted by climate change. This has to start now and it has to be completed in the next 3 decades, so it's quite a task. I don't think it's impossible. I think it's incredibly unlikely. I think we're going to choose to fail. But I think we actually have the wherewithal, the capacity, and to some extent, the individual compassion, but we have no way yet of somehow bringing that together collectively to say this is a really important thing that we should be doing. So I think we could move in the right direction. And I'll finish on a message of hope from Robert Unger that I always use, that at every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. And the future will be radically different, either because we've done something significant and quite heroic in terms of reducing our emissions rapidly, or because we've not bothered to do that, and then we'll be impacted by significant climate change. So the future will be radically different. And our job in universities, I would argue, is what we're paid for, is to go away and imagine what would we have to do to move us from where we are today to a low-carbon future. But that's not enough. We then have to provide some clarity. How do you convert that imagination into something that policymakers, businesses, and wider civil society can actually act upon? So imagination is quite good, but we need to go a bit further than that and provide some sort of stronger wherewithal in terms of the fleshed out ideas for policymakers. And I also think it's important in our universities, it's not just about scientists or engineers. This is about the social scientists. It's also about the humanities. Now, I like PowerPoint presentations. I like numbers and I like graphs. Most people aren't interested in many of them. There. So we need to engage with people who communicate through other forms of media. And it doesn't mean dumbing the message down, but putting it into soaps, into songs, into things that we read. It needs to be a message that percolates through society, not just to a few people that turn up for events in the evening. And perhaps sometimes you need to discuss it not necessarily in the language of CO2 emissions or climate, but in other ways to think about these issues. But that's not my job as an engineer. We have to pass that baton on to the arts, to the humanities, to think about those issues of communication. So on that final note, thank you very much for listening.
Thank you very much, Kevin. So now we've got time for some questions. If you're watching online and you want to submit a question, please do so over Twitter with the hashtag that's shown below there, and we'll take the online questions in a minute. But can I take a question from the audience, first of all? We'll do this side first. Okay, at the back there, please.
You mentioned that offsetting was possibly worse than useful.
I'll try and do it really quickly. Yeah, just imagine, right, I'll give you an example. Imagine we're going to fly somewhere, right? So we offset. Now, when we fly, what we're saying to the airport is grow your airport, as every airport is growing, and buy some new planes. It's a market signal. And so and when we put the CO2 in the atmosphere, we then pay someone, let's say we pay an Indian village to put up a wind turbine. So the Indian village has a wind turbine, which is great. They've now got electricity at night. So they can put the lights on, they can do the homework, whatever they do with electricity. Also means they've now got television, which means they can watch TV, which means that advertisers can get to them. So then a small scooter advert company advertises its scooters in 5 years' time, says, why walk everywhere? Why not get a little scooter? Then a small petrol depot opens, then another 5 years' time, a pickup truck manufacturer says, you can buy the second-hand pickup trucks now and use the fuel that's set up for the scooters. Yeah, it's all part of development. And that's more CO2 emissions. So yes, it's good for development point of view. I'm nothing against doing that, but it does not offset the emissions that we pump in the atmosphere from flying. So I would argue it's worse than doing nothing from a carbon perspective, but it can be good from a development point of view.
Okay, and a question on that side of the room, please. Thank you.
Hello, Bill Powell. I served twice on the Lib Dem policy working paper, and the man who Duncan Brack, who's just written a controversial paper for the Chatham House. He was a fellow member who I disagreed with. That's the way of the world. You have come down heavily in favour of increasing the electricity capacity. I take issue with that because I think the quickest and simplest thing we could do is to turn the gas network green. And we could do that through biomass, not necessarily from trees. There are much faster growing crops such as bamboo.
Yes, I agree to some level. My colleagues have worked on biomass say if you tried to convert the gas network to the total amount of gas that we use now from biogas, you couldn't do it. You can get about 10%. So the people who have worked on this say if you really pushed biogas, you could probably get 10% of our current gas use from biogas. And as you say, it doesn't have to be trees, it can be lots of other forms of, and in fact, you can be anaerobic. In Sweden, they run their buses on biogas in a lot of the parts of Sweden. So biogas can and is being used, and there isn't enough material out there to make the sorts of quantities that we use gas at the moment. But we could be much more efficient in our use of it, of course, as well.
Efficiency also comes by using it.
Yeah.
And estimates that I've seen are that it could reduce it in the gas economy, if you like, which could be hydrogen or synthetic natural gas, by a factor of 4 end use.
Yeah.
I've gone over numbers, and I think it's a factor of 3, but it is very, very substantial.
Yeah. And certainly when you put in hydrogen, that gives you a lot more opportunities. But at the moment, the manufacture of the hydrogen is still problematic. But yeah, I think we should be looking at these technologies, and some of them already work, and we should be applying them. The ones that work, we should be applying them today.
Okay. We want to take some online questions, do we? Twitter questions, yep.
Yeah, we can do. Thank you. So I've got one here from Max from Germany who says, what does the average individual who's a top 10% high emitter do daily to emit such high amounts of CO2?
I'm sure it varies quite a lot, but actually there's an interesting post by Peter Kalmus, who's a climate scientist in the US, who stopped flying a few years ago. And he stopped flying when he plotted his emissions. And I think it was about 50 to 60% of his emissions were his flights. So it's the biggest thing he could change. But it would be worth looking online for Peter Kalmus. But for the high emitters, the flying will probably be a large proportion of that. But a lot of it also will be that we tend to drive further, we drive bigger cars, sometimes we will travel first and business class, and our houses will be larger. Now, sometimes that doesn't mean that it's more energy consumption than the average house, because the average house in the UK is so poor. But if you go somewhere like Sweden, the bigger house does consume a lot more. So it depends if you live on that, on that level, and depends upon the individual houses themselves. But then also beyond that, if you take the Chancellor and Piketty report, which is really worth looking at, the one that points out about the big CO2 asymmetries, then the amount of stuff that we buy, if you're quite wealthy, you buy lots of stuff, and there's lots of carbon wrapped up in that stuff. So there's a whole suite of things. It would depend a bit on the individuals you're looking at. And meat eating also makes quite a big difference as well.
Can I take a question in the middle over here? Can you get the microphone there? Thank you.
Hi. So there's a lot of discussion about supply side policies that limit, obviously, the supply and try and encourage low CO2 technologies, but there's little discussion about limiting the extraction of carbon. And when we're talking about carbon budgets, obviously as the amount of carbon that's being extracted is going to reduce those budgets. So is it realistic to have any policies that reduce extracting countries?
Yeah, I think completely. And ultimately, at the end of the day, it doesn't matter how many wind turbines we have, how many solar panels we have. None of that matters from a climate perspective. The only thing that matters from a climate perspective is keeping CO2 in the ground, carbon in the ground. So we have to, at the end of the day, we've got to keep about 80% of known reserves in the ground. 80%. But anything like sort of 1 up 2 degree C framework. So we need policies to do that. Now we can start off. The IMF estimated that in 2015, the subsidy to fossil fuels, this includes direct and indirect subsidies, significantly driven by health implications, was $5.3 trillion. $5.3 trillion. You know, that's, what's that? Is that twice the size of the UK economy, something like that? It's getting on for size now. That's a subsidy to the fossil fuel industry. That's not all direct, a lot of it's indirect. So we need to be stopping doing that. But why in the UK are we giving tax concessions to shale gas? Why have we given more tax concessions to the North Sea oil industry? Countries like the UK and countries like Norway, who are incredibly wealthy countries with a very highly educated population and tremendous renewable potential, we have to demonstrate leadership here. And if we do not close down, phase out rapidly our oil and gas industries, then we're going to fail on climate change. We are a really good bellwether for whether we genuinely at a global level care about climate change. It's harder to imagine the poorer countries doing it because they might want their oil revenue. But we can get away without that oil revenue. So we have to be doing that, yeah. So it's really important we close down the extraction industries. And I apologise to my colleagues in the oil industry if any of them are listening tonight when I was there years ago. But there's plenty of renewable jobs out there.
So can I actually ask you a question? So you mentioned the UK's policy position, and in reference to whether it's consistent with our signing up to Paris, and you mentioned that the UK position currently is based around 63% chance of meeting 2 degrees. It's also based, I believe, the 80%
of exceeding 2 degrees.
Of exceeding 2 degrees, indeed. It's also based, I believe, 80% reduction by 2050 is based on us doing our only as good as the global per capita average, right? So a combination of well below 2 degrees and the equity component of the Paris Agreement, do you think that's consistent with what we're doing?
Not at all. I've had this discussion with the CCC as well. Now, when you think about it, what we're saying at the moment, we've also got in the UK policy an 80% reduction in our emissions by 2050. And when you think about that, what that means that up until 2050, up until the morning of the first day, January the 1st in 2050, the emissions for the average Brit will still be higher than that of the poor parts of the world. So we increasingly, we already take a huge historical responsibility for climate change, and we're going to increase the level of historical responsibility right the way through till the end of 2049. That is completely morally reprehensible. And yet that's the framework we've got, because we've got to have one that's politically, that fits with the current political paradigm. I don't just mean the Conservative one, the Labour Party are no different, unfortunately. So no, it's not right at all. The other thing to bear in mind, I'll just touch on it very quickly, is that most of the time when people think about these carbon budget frameworks, they don't think about the poor parts of the world, for instance, trying to produce cement to help them grow their industries, to industrialise. Cement has very high levels of emissions from the chemical processes of making it. You can make it more efficiently, but there are no ways to eliminate the CO2 at the moment. And yet, if you then put these constraints in other countries from a CO2 perspective, that means they can't use as much cement. That means they can't have foundations for wind turbines. They can't put in sewage pipeworks and things like that. Cement is the second most used material on the planet. It's essential for industrialization and development in some of the poor parts of the world. So I think that should be a global overhead, not taking account of only in the poor parts of the world. And so you can make the same argument for deforestation. We've got 11% forestry, I think, in the UK. We've deforested already, so we've got lots of land for farming and other things. And we complain when other countries do it, and we put their carbon emissions from their deforestation on their budget. There should be a global overhead as well.
Okay, more questions in the middle desk there. Yep. Can you wait for the microphone? Otherwise, people online can't hear you.
No.
So I have a question about opinion of the future.
Where are you?
Hi, I'm here.
Oh.
Hi. I wanted to ask you, do you believe that other coming crises will actually help us reduce our carbon emissions? By that I mean, hoarding of resources, rare earth metals and so on that are needed to continue the economy, deglobalization, wars, famine due to climate change, meaning that people can't actually work and produce the goods for the first world, you know, a sort of economic degrowth involuntarily. Do you think that will actually reduce? So it's a terrible world that I'm talking about, but do you think it's one in which the climate impacts will be reduced compared to the business as usual, assuming everything else is great in the world?
Yeah. I don't think there's a simple answer. I don't think we know the answer to that. But there are some things. So, for instance, the 2007 banking crisis was an opportunity for the climate change community to come forward and say, let's think about this differently. We haven't done. It's an opportunity for society to do that. We've had really weak regulations put in there. We've still got casino banking. Trump's come in dismantling the few weak regulations they had in the US. We've gone back to the same system that they had before. That was a real opportunity to think differently about the world economy. And that's why some students have been asking for post-crash economics rather than that U-shaped marginal cost nonsense they usually get taught. So there are people have asked something different, and we've failed them. We haven't succeeded in that.
I completely agree.
But maybe actually, I think now might be interesting. I think Brexit and Trump are interesting. I happen to vote to stay in, but that's almost the Senate doesn't matter. And I think Trump is a repulsive individual. But he's the American president. We have to show respect for that office. But I also think that actually the reason that we had both of those is because left-leaning, well-meaning, woolly liberals like me haven't shown sufficient care and compassion for a large swathe of our society who have not done well out of globalization, either relatively or often, even absolutely. And that actually we should start to listen much more to what their concerns are. And I think actually their concerns do actually align quite well with dealing with a lot of the issues to do with climate change, and from an employment point of view and lots of other benefits as well. So I think there are ways to rethink what we're going through at the moment in a much more positive, constructive fashion. In addition to that, Trump says he likes protectionism. Protectionism actually is not always a bad thing. Most poor parts of the world desperately need it to ever thrive. But if he wants to have high carbon, if he wants to go back to coal, which I don't think he'll get the investment for anyway, but imagine he does in the States, that's fine. He likes protectionism, so the rest of the world can start to put a carbon tax on American goods they export. He would agree with that, presumably. That's our choice to protect our industries. So we should be thinking about those sorts of things as well. There are lots of opportunities to use some of the big changes we're seeing now to think differently about the world in which we live. If we're going to wait for the physical impacts of climate change to kick us up the backside, I think it's going to be too late, particularly as people like us will not feel them initially. The poor people in our societies will start to feel them, but obviously the poor people elsewhere will feel them well before that. By the time it gets to us rich folk like us, then I think probably it's too late. But we know everything we need to know to start to act differently now.
Thank you for that antidote to fatalism.
Okay, can I take a question over here?
I absolutely agree with you about the importance of the simple choices we make in our lifestyles and our behaviours. And I mean, I guess it's roughly sort of 50% of the solution is in those simple choices. And so I was interested in what research was going on to monitor the extent of those. Because of course, the consumer interests, consumer companies aren't going to be monitoring that. But before you answer, can I just do a little experiment? Who here has not flown in the last 12 months, the last year? Not flown in the last year.
Fantastic.
Who here is actively trying to reduce the amount they fly? Hands up.
That is fantastic.
Yeah, but it's Cambridge.
From my work in innovation, I know that often these changes happen below the radar, and they sneak up on people. And clearly, this is not the typical UK citizen group, as you said at the beginning. But I think I'd be very interested to know what research is happening, or should more be happening, to monitor these hidden trends.
I mean, I have colleagues that look at these sorts of issues, and there is some research. The demands, there were a series of demand centres set up in the UK. I think there were 5 of them, set up different parts of the UK, looking at issues of demand. I don't know how many of them have been looking at these sorts of, what you're talking about there, in sort of levels of detail. Some have been looking at some of these behaviours, and some people also look at it in terms of what they call practices, and there were sort of social norms rather than actual behaviour. The psychologists tend to think of it as behaviour, and the practice theory think of things that we're sort of locked into through these sort of norms. But it's fantastic to see that. I mean, it's true, it's in Cambridge, and it's not it's a climate change audience. But nevertheless, it's people of our income, it's people that live on our streets and houses like us that go to our universities that are driving innovation and driving some other things. So actually, that is quite interesting that you start to see there's a sufficient number of people there to start to catalyse some sort of movement. And I've seen that in other parts of Europe, where people have started to think about the way they're trying to do what they're doing, and including some people in their universities and the divestment movement. So there are plenty of, Naomi Klein makes this point, there are lots and lots and lots of disparate groups trying to do good things. The problem is there isn't any way of coalescing them. And if you did, you can make what effectively is the powerless very powerful. Because ultimately, at the end of the day, a handful of CEOs are not more powerful than the mass swathes of people. But whilst the mass swathes of people are not unified in some way, and I'm not saying that's easy, I don't know how you do that, then they can generally rule the roost. So I think that's a really good sign to see that sort of level of mobilisation on an issue. We need to be vociferous about it, perhaps we all are being, but we need to be vociferous because people have to see it working elsewhere.
Okay, I'm going to take 2 quick questions. So I'll take one right at the back over there. Yes.
Try to keep quick answers.
Yeah.
Hi, I wondered if you'd read the Task Force on Climate-Related Financial Disclosure report recently, came out in December, and they included that they wanted to include scenarios, and basically the different financial assets that you've got are linked to different scenarios, and start including those scenarios in your financial reports. And they had a lot of speculation. Obviously, it's written by the financial community rather than being a wave. But did you have any kind of thoughts around the input the financial sector can have? Say, for example, like one of the big banks already on their default pension fund includes 3 climate criteria. Like, what have you seen or measured or been involved in any kind of scenarios around the financial sector improving the situation for us in the carbon budget?
Only indirectly. It's not my area, but I have been involved in some discussions with the USS, the pension company for academics, and they've been seriously looking at issues of divestment, and right to the very top level, CEOs and their financial director as well. And I know there's been a lot of discussion about issues of risk. You brought up in the previous talk that there are ways to financialise risk, which then plays out in things like assets and so forth. It's not my area. I'm aware the financial industry, the insurance industry has been thinking about, the insurance industry has been thinking about these issues for a long, long time, and the financial industry is sort of waking up to them. So these are moves in the right direction, but I really couldn't make any other more informed comment on that. Sorry.
Okay, so who wants to ask you? Oh, there's a competition between the 2 of you. If you ask really quickly, I'll let you both have them. One, but they're the same, one after the other, and then you can answer both together.
Okay.
Okay. I'll ask the question one after the other, and then again, keep them brief.
You made the point that there's a lot of carbon tied up in things. Power stations are things, and my understanding was that there's several years of energy tied up in a power station. Yeah. So to build all these power stations is going to take a hell of a lot of energy and a hell of a lot of carbon, and is that taken into account in working out all the carbon budgets?
Yeah. And before you answer it, I'm going to get the other question as well.
What about meat, the livestock industry, and also children, at least for the richest 10% or the biggest 10%?
Right, the first one, power stations. Well, yes, what it is, it's a taken account in the carbon budget. In other words, the transitions you have to make have to be within those carbon budgets. And you're right, making the transition to low carbon infrastructure will be very carbon intensive initially. And that's why I'm quite specific, saying you have to change the productive capacity of your society. So if you're not building some of the other things that you want to build, and you're building power stations, you don't necessarily see any change in your carbon emissions. And that, I mean, that is really important. It's important from an employment point of view, important from a resource point of view. It's a bit like in the Second World War when, was it Roosevelt? Went to the car companies and said, we need to be building all these planes. This is what we can't, we're building the cars. And he said, you don't understand, you won't be building the cars. And that it's, if we're serious about climate change, it is that sort of agenda we're talking about. And therefore, you don't necessarily see any significant increase in the amount of carbon emissions. But no reduction either, because it will be very carbon intensive. Meat and children. Is there some way to bring them together, which is not too... well, yeah, meat is really important. Other people here will know much more about that area than me. Agriculture and land use represent probably 25% of the emissions, depending on how you measure these things. There are different ways of measuring them, different years over which you integrate them and so forth, but it's very important. And there are significant things you can do almost immediately by changing our habits in terms of eating habits. We do know that very clearly red meats, ruminants are really bad. You know, even ruminants brought up well are really bad. Maybe not nice in the countryside. I live in the Peak District. I like seeing the sheep there, but nevertheless, you know, they are a problem. So sheep and cattle, move to pigs and chickens. These things we know are much lower emissions, and try to eat much less meat. Being vegetarian makes a big reduction in the emissions. So they're very clearly categorised out what you can do. And obviously less meat and food waste, all those things help as well as actually having smaller fridges and freezers. So there's a whole suite of things you can do. In terms of children, oh dear, what can you, don't have them. We've got 7.4 billion. Do we need any more? Adopt them or get back into communities and look after someone else's kids. You know, so they can go out for weekends. I don't know. And I'm not sure nuclear families are it's not me. I'm not sure nuclear families are the way for a long-term sustainable society to be. But yeah, maybe we should be more, yeah, like communities and tribes as we were years ago. And the kids ran sort of, well, my vision of that time, they ran riots and we all sort of looked after them. They were the children of the community, not just of the parents. But I don't know, only have one or two and bring them up so they're low carbon if you can. And hopefully they'll start to pester the parents. But then they turn into teenagers and try to buy everything. So you can tell I'm not a parent, can't you? I was a child once.
Kevin, thank you very much for a, I think, shamelessly blunt. but in your shamelessly bluntness, you really do cut through to the key issues associated with all this and bring a really important sense of clarity to these very, very important policy relevant decisions that are going to affect all our futures. Yeah. So thank you very much indeed.
Thank you.
Thank you. Thank you to everyone for coming and to those watching online. Next week is the Science Festival, Cambridge Science Festival, and as part of that we have a panel discussion. So you're going to be coming along, are you?
Apparently, yes. I've got some new ideas for next week.
Exactly. And a number of the previous speakers are also going to be there. It's going to be chaired by Oliver Morton from The Economist. So please come along next week for what should be a very interesting discussion. And if you want to stay for some refreshments now, then they will be outside and we'd enjoy talking to you further and continuing these discussions. So thank you very much indeed.
Thank you.